Oh.
Oh, I think you did
So much. I'm just gonna watch movies over here. And next year.
Yeah.
Sure. Like the bottom street.
What? Wait, no, there is no bottom. So initial velocity is 0, we know the acceleration, we know the time, we know the distance. So with Rachel, we have the 10.1 being much more. We get almost 8 to
Yeah.
yeah.
Mm-hmm.
Yeah. Rachel, engineering. Why do we need to
use that one?
What?
I don't know what I'm doing. I used the first one. But then that gave me the final. I don't know where it's going with that.
Final.
Or like the final.
The final.
I used this one because it's like, oh, I have to stuff shit.
It's a Monday, John. I was going with John, you know.
There's no more John.
John. I think Johnny to lasagna.
Alright.
8:42.
What's that music?
Yeah, I think it's
Like,
yeah, with the circle. Yeah. I think it's been there for a while now.
either I just noticed it or I have short-term amnesia.
I'll probably both. How's it my fault?
We bought water and stuff.
Also, those are those wood salts for $4 each.
Wood
So
sauce.
wood salts, they're not very good.
So I think we need the water blue part. I can assure you.
They also sell. They also usually sell axes, and also all the stuff, the lay knives.
calculated sort of the calculus, the term.
Over number one in a second here. Elin, can you just turn on the projector, please?
It's like with this, checkers. Oh my god.
Okay, let's look at number one. So you've got I'm just gonna, it's a wagon, but could be anything. Okay, it's being pulled along the ground. It's being pulled by the handle. That's your FA. I call it FA. This is your FX. And FA makes an angle of 40 degrees. Okay, so before we begin, we know the relationship, I wrote it up previously, between cos and FX and FA. Okay, so FA, that means FA is just FX over cos. So once we find FX, we have FA. That's the point. Try to find FX. Okay. We have the force of friction. Same equation as I wrote before. F net is equal to Fx minus friction. So I have my acceleration. I'm just going to use positive values with these equations the way I set them up. So that should work out to be about 42. Let me look at it. So 36, yeah, 42 newtons. And then you use this. That should give you 55 newtons. Okay. And the next one is 3. How many of you finished 3? I think most of you, right? Anyone still working on 3? Okay. So read it over again. I'll go over it. Very similar. It's not as tricky as you might think. Now you're pushing down another 150. So you have the applied force. Okay, the angle is 60. And don't forget, you still have friction. Okay, plus this component. This is an FX. They're pointing in the same direction. Oh, pardon me. They're pointing in opposite direction, just like the equation above. So you have FX pointing to the right. And friction pointed to the left. Now you have the FX. You don't have to solve for it. You're solving for, in this equation, the acceleration. So we'll get to that in a minute. So we have I'll do it the way we did before to avoid confusion. So we have the cosine of 60 is equal to the adjacent side over the hypotenuse. So Fx over Fa. So we want the Fx. The Fx is just Fa times cos. Which works out to be 75. That's your FX. This is your FX here. So we have F net, same equation as we did in number 1. You can just plug in our values. We have for the mass 20. You have the FX 75. For the friction 25. Okay. And then obviously it's to the right. The way I drew it, it's to the right. Okay. How many people finished 7? Anyone not finish 7? Let's look at 7. Just reread that. This is a different type of problem. This is an incline problem. Yes, it mentions an angle, but you got to make sure you understand. It says, it uses the word plane. It's another word for incline. Or slope. Plane that's inclined. Okay, this is actually the word you're looking for, inclined. This plane is inclined at 15 degrees. That's the word. Incline or slope. I'm going to use a block. It doesn't matter what the object. Well, usually they're referring to some sort of block. Okay, so they say that the force of gravity on the block is 20 newtons. So M is equal to Fg over 9.81. We're going to need the mass, so I'll calculate that right away. That's about 2. I'll get more an exact value here. 2.04. Is it given? Oh, okay. Usually they don't do that. So it is 2. It is 2. They gave you the force of gravity. I didn't notice the mass. But if they give you the force of gravity, usually they won't give you both. So you have to calculate the mass. What is the acceleration of the block down the incline? So it's smooth. Okay, another word that stands out, it's smooth. What they mean by that is no friction. So what's the force that's pulling it down? It's the parallel component that we talked about, Fg parallel, that's pulling this down. So F net is equal to just Fg parallel. There is no other force acting against. Friction is 0. Usually I'd subtract friction. It's 0. So that is your net force. Okay, now, this doesn't always work. In this case, we didn't even need the mass. The mass is common to both terms on the left and right, so it cancels out. Down the plane, down the incline. Okay, that's part A. Part B, how far up the plane was a block released? So let's make a list. It's released, so that implies it's released from rest. Okay, we want to find D. I got it. I didn't, here you go. I got the book cards and that. I don't have my health. I mean, I can give that to them later.
Okay.
Yeah, I got those. Okay, so your initial velocity, like I said, if it says, if you see the word release, that implies from rest. So this is 0. So the whole term is 0, cancels out. I'm just using positive values. I can do that. I'm just interested in the distance. How far implies just a distance, just an absolute value. Okay, as far as the test goes, this is not thorough. I'm going to give you more thorough, a little more thorough on Teams this afternoon. So it's adjustable, but it'll be what I can recall. Here's just the basic breakdown. So for the forces test. Seven to 9 multiple choice. Okay, they'll be worth 2 marks each. Show all work. Whenever I give you multiple choice on a test, I've got time to go over it again. So show the work. I can give you partial marks for even a multiple choice. I can do that for a test. It'll have 3 to 4 written, worth 5 to 7 marks each. Okay. I can get to more specifics later, but there definitely will be, first of all, probably one of the written will be questions on just stating Newton's 3 laws. Just state them. I'm not even, as far as examples, just state the 3 laws. So that's definitely going to be on there. Worth about 6 marks. I can't give you the mark breakdown definitively, but that'll be worth about 6 marks. There definitely will be some incline problems in the multiple choice and the written, at least one in the written. I'll go into more detail as far as the breakdown of that later, but there's going to, yes, definitely be incline problems, solving for the acceleration, solving for how far down, solving for how fast. Yes, at least one in the multiple choice. At least one or two in the multiple choice, and for sure one in the written. Okay, that's 2-part, right? Usually the first part is solve for the acceleration. And then part B will involve some sort of kinematics, solve for how far it moves down the incline, how long it takes to move down the incline given a distance, how fast it is when it reaches a certain point or after a certain amount of time. So the second part will involve using kinematics as well. There'll be definitely some friction problems along the ground. So friction involving a horizontal force. It's what I first reminded you of on the left side, far left side on the board here this morning. Something like that. And I could mix it up, right? The typical one is solve for the acceleration. But I can mix it up. I can instead ask you, given the acceleration, solve for the friction. Solve for the fx. Any of those questions. Same equation, it's just you need how to rearrange it according to what the unknown is. Okay, so there's definitely one multiple choice question on that, and there'll be one written on that too. The written I've got to make some changes, but the written may include, again, some kinematic equations, so just keep that in mind. So how far does it go? Given the acceleration, how far does it go? How fast is it going after a certain amount of time? I would expect in the written part, both the incline and friction show free body diagrams. That's in the written problems in general. I'll state it for clarity's sake in the problem, but in general, in the written problems. Whoa. Okay, there will be definitely some elevator problems like you did, similar in the assignment. Okay, for details. Now, as far as the assignment goes, here's the problem. You will get it back tomorrow. But I don't know if I can post solutions yet. I'll go tell you by break. If I got them all in, then the solutions will be posted tonight. You'll have it back tomorrow, yeah? Yeah, I got him here. I'll give him back to you at break. I said I would. Yeah,
I have a question about the elevator problem.
yeah.
If we are not like given both the forces of tension, so what is the basic formula that we use?
What's the what? The last
What kind of like the formula we can assume?
for the elevator problem? Yeah. So
Because you told us there would be like, we saw the exercise, the three questions, where we were given that if it's going downwards, then, force of gravity is more, and if it's going
yeah.
upwards.
So it could be any of those three, right? So the elevator problems typically have just three types. It's accelerating up, and you'll be asked to solve for either the tension. That's a typical question. What's the tension? Or I could ask, given the tension, solve for the acceleration. Okay, that should be not deep, but up. It could be accelerating down. Okay, again, solve for the tension or the acceleration down. Give me a direction with both. Remember, don't forget to do that, even though it's obvious. Show me the direction of both. If you draw in the free body diagram properly, you should be able to figure that out. So make sure, again, with even the elevator problem, you know how to draw a free body diagram. And then the last type of question is moving with constant velocity. Or speed, either term. They'll use constant velocity or speed in the problem. Up or down, doesn't matter. In that case, the forces are balanced. Okay. I think I went over most of it as far as what to be aware of. Just one more point. Okay, with the friction involving horizontal force, sometimes you're asked to solve for the coefficient as well. I'll add that in there. And this is pretty thorough. I don't know if I'm going to add much more tonight on Teams. That's probably it. I've got a review booklet for you. I would still make sure you go over all handouts and all the questions that we did in class. I will give you the review later, but be careful with this review because I've got to narrow down the problems. I'll give you a list as far as what to cover. This is not by any means thorough, but it'll definitely cover some of the questions that I just pointed out here. Okay, so back to momentum. Now we can go back to momentum. Okay, I left my small little book. Leave my book in the car. I left the book in the car. Okay. We're going to go over these questions here, where we left off. I think this is it here, right? 175 and 10. Just read it over. Go back to 175 on the handout. Read that over to yourself.
Yeah. Why is it changing?
Okay, so let's look at this here. Yeah, we have. I'm going to use impulse. See if this works. Okay, if you read the problem, this is 0. Comes to a stop. I'll just call it F. I know it's a net force, but I'll call it F. Okay, so the negative means it's in the opposite direction to the velocity. So the velocity is north. This is going to be south. You can leave it as negative. You can put both if you want. South, newtons. Oh, we'll take a look at number 11. Keep in mind, this is what you're given on a formula sheet. You have to realize it's this equation here that I wrote down. Change the right side, expand it. From rest means VI is 0. Okay, 12. Look at the expression, change in momentum. Okay, now that is equal to this. That's what the right side usually is referred to, but it's also equal to this. They're equivalent or equal to each other. So you use whatever expression is convenient given the information. So in this problem, they give you the force and they give you the time. The change in momentum is, yes, I know it's a net force. I'm moving fast here. You done? Here, oh yeah, don't put it there because I'm going to lose it. So. Okay, so force is 25 and the time is 7.2. In the same direction as the force, so it's north. Change of momentum is in the same direction as the force. Oh. Give me a minute. Okay. 13. And so 13 is asking you for the impulse. Again, impulse is either expression. It's that, or it's this. I'm going to use the second one because I'm given the velocity. So you choose whichever one you're given information for. That's the one I used. I'm going to give you the answer to that. 75 kilograms meters per second or Newton seconds. And it's east. It's moving east, so. $15 or 14. Read that. I think that's a little more involved, so I'll go over that. Oh gosh, what the hell? So I've got the D, I got the T, I want the VF. I got the D, I got the T, I want the VF, I got the VI. VI is 0. D is 26.3. T is 3.2. So that's 0. So that should work out to be 16.4. And it's going to be west. Okay, so the question is, what is the change in momentum? Same direction as the final velocity. And 15. Just read that again to yourself. Okay, it's dropped. That means its initial velocity is 0. It falls a distance of 6.5. It's negative. It's falling down. Acceleration, we know. Okay, we can find the VF. We'll come back to that. Oh, okay. I see what they've done. They've said it's dropped from a height. Doesn't fall that total distance. So let's go back to this. We don't know how far it actually drops when it's got a momentum of 6. That's the question. How far is it fallen given this velocity, which we're going to find out from the momentum? So the momentum we are given the momentum, it is 6. And yes, when I plug it in, if I'm going to use it as a vector, as I have to with the kinematics, it is -2. Now I can solve for the D. I use the equation that contains all 4. and it only falls a distance, the displacement is negative, but the distance that it falls is 0.20. So be careful. Sometimes they do give you extra information like this problem. They told you the height, you didn't need it. Doesn't fall at full height. Because if you look at the question, it says, how far has the ball fallen when its momentum is 6? So at that point in time, not necessarily all the way down. Okay, so what time is it? 6:30. It's 9:30. 6:30, that'd be funny. Now, more questions. $183. $183, $184. What did I say? 1, 2. Was it 1 to? Make sure I get that right. Yeah, 1 to 9. Okay, we're not going to get through all these. We'll get through some of them. Let's see. Okay, let's read over 1 to yourself. Okay, so in this problem, there's a collision. So that's the condition you're looking for, collision or pushing or exploding apart. Then you use the conservation of momentum. Okay, so collision or explosion or pushing apart. Okay, any of those 3 conditions imply use this law. Yeah.
For momentum, it says certain amount of kilograms per times meters per second. What is it increasing? Like, what is that?
What is kilograms meters per second?
Yeah. Like, what's happening?
It's not, it's a mathematical concept. So there's nothing physical you can say. It's a product of mass times velocity. So there's nothing you can look at. You can't compare it to something like a force where you can understand it as a push or pull.
So like in the moment, let's say.
In the moment of the collision, or
In the moment of like seconds, right?
are you talking about a collision?
Not exactly. I'm talking about like if someone riding the bike and they're accelerating faster, just like the momentum builds up.
Yeah, all you can say is mathematically, if the momentum is building up, then the mass is staying the same in that case, right? So the velocity is increasing.
Okay,
That you can picture. You understand? You understand physically what I mean when the velocity is increasing. But to say the momentum is increasing, you're just saying a product is increasing as a result of either the mass or the velocity increasing. It's a construct. It's a, like I said at the beginning, a definition. A helpful one, because you can come up with, you can relate it to force, or you can relate it to something that's staying the same. When we use the word conservation, we mean remain the same. Remains the same.
So, just hold on. For momentum, is there anything to plug into it to get a different result?
Is there anything to plug in? Usually we apply it to what we're using it for now, conservation. So it's used to predict usually a future speed or velocity. Given the initial velocities, predict the future velocity. Yeah, usually. Okay, so that's what you're given on a formula sheet. You need to be able to translate it to this. This is your responsibility. You want to use 1 and 2, you can use A and B. That doesn't matter. What's important is you understand the left side is before. Okay, 1 and 2 implies there's 2 objects. You could have 3 objects, 4 objects. Usually it's 2. Before the collision, or what I mentioned up here, explosion, pushing apart. And the right side is after. After. That's why I have noticed that the velocities on the right have these little primes. That's to remind you that those are different velocities. Right? V1 prime does not equal to V1 necessarily. It can in some rare circumstances. Well, it won't. Yeah. They're different values, different directions. That's what it's to remind you of. Okay, so what we're doing in this set of problems involves momentum along the x-axis. It's linear momentum. Linear momentum. What does that imply? That implies simple math. Add and subtract numbers. That's all you're going to end up doing. That's what you learned in grade 11. What's coming after the break is 2-dimension, where it's not simply adding and subtracting. 2-dimension means the vectors are not parallel. They're in different directions, so we need to break them up into components. Okay, now we look at number 1. So just, we have, like I said, we have 2 objects to begin with. They're both moving. That's not always the case, but they're both moving in this case. Nothing's going to cancel out. Usually something cancels out or simplifies. Not in this problem. We need all 4 terms. So you have a 30 kilogram. That's good. Usually the first object mentioned is M1. Okay, anything that's moving to the right is positive. There should be a 2 here, not clear. It hits a 20 kilogram object. Moving to the left. And left means put a negative in front. We don't know what the V1 prime is. That's the question. That's what you're trying to solve for. We're told after they hit, the 20 kilogram continues to move to the left. It's slowed down though. It's gone from 5 to 1. What is it? 1.25. Okay. You're just going to take this term here, subtract it from these 2 terms, and then divide by 30. Okay, now you're gonna take both sides, divide it by 30. Remember, when you're dividing more than one term, draw a line underneath all the terms like I did on the left. Draw it all the way over to the right like I did from here to here. And the 30 will cancel out. That's how you get your V1 prime. And you get 1.5 to the left. You can put negative or to the left. Okay, we'll do one more problem, then you get your test back. You happy? Good. Okay, read over number 2. Okay, so it is a collision problem. So I just went straight into the equation. I didn't simplify it and cancel anything out yet. That's going to change. If we reread it, it says this 4,500 kilogram car, railway car, is moving to the east, moving to the right. So it's going to have a positive velocity. It hits second stationary one. Stationary one implies this. I'm going to call that object 2. That's 0. V2 is 0. These are just numbers. And 0 times anything is just 0. So that whole term is going to cancel out. So I'm just going to be left with M on the left, M1, V1. On the right, they stick together. If they stick together, they're no longer separate. That means that you could think of it as one object. It's not. You could call it. You could say. You could do this. M1. Drop the subscript. That's the easiest thing. Call it V prime, which means, why did I do that? Because they're both moving with the same velocity. So I don't need a subscript to distinguish between the two. So just drop the subscript, call it V prime. Means the final velocity of the two objects that are stuck together. Okay, you can simplify it further, factor out the V prime. I'm going to rearrange it. I'm not going to plug in yet. Why? Because you use this a lot. That's why. So know it. What's this equation? It's the equation that you'll use when two objects collide. One's initially at rest, and after they hit, they stick together. That's when you use this equation to solve for the final velocity. It's a common velocity. Okay, so you can just plug in 4.5 times 10 to the 3, that's the first one. Moving east, so that's a positive. 4,500 plus 6,500. Okay, and they move off together. It's positive, you can put east or both. Okay, so I'll get you your test back. Everyone's good. Alexa, Sarah, Muriel. Muriel, you're right there.
Oh,
Praise. Darwin.
but that.
Good. Angie.
What? This.
Bill.
Thing.
Joseph. Nora. You asked is not here. Okay, take a break. Oh, I'm gonna forget this because as far as the forces test, I didn't, what you just went over, forces on the angle, yes, there will be one question on that as well. Add that to the list. It just popped in my mind. Oh, not now, just break.
And I want to ask one question about.
What happened? What's going on? Why am I getting, remind me later. No, give me a second. Sign off. Okay.